So in chapter P6, we're going to be factoring polynomials. So every one of these sections that we're doing is really important because they're all different rules that we'll be continuously using. This section is really important. Factoring is used all the time, and it's essentially you're never gonna stop using it. So what we're going to be doing is starting off with a polynomial that's expanded out, which means it is a sum of monomials. So that's what this part means right here. So it just means that it's expanded. So when we factor it, we're going to rewrite it, which obviously it's going to be an equivalent expression, but it's going to be an expression where it is a product. So it's going to be things being multiplied together, and those things being multiplied are the factors. So for example, if we have this example down here, 10x squared plus 15x, that is the sum of monomials. 10x squared is a monomial, 15x is a monomial. It's the sum, they're being added, so it's expanded out. What we're going to be doing is we're going to be factoring it. So we're going to go from that left-hand side and we're going to factor it and say that it's the same thing as 5x times 2x plus 3. So 5x would be a factor here, and so would 2x plus 3. So you may notice that this direction over here, this is distributing. So essentially factoring is one direction, going back the other direction would be distributing. We would distribute the 5x throughout those two terms and get what we started with. Not every single polynomial can be factored, and if they can't be factored, they're called irreducible or prime polynomials. So the main four types of factoring that we're going to be doing, this isn't the only methods for factoring, but these are essentially thought of as like the main four. Greatest common factor, which we call GCF. And then there's going to be grouping. There's going to be trinomials in the form ax squared plus bx plus c, and then the difference of two squares. So I'll go through and do all of those, starting with the GCF. So usually in the first step for a question, for a factoring question, or if we have to factor, is going to be look for a GCF first. Look for the greatest common factor first. So the GCF is going to be an expression of the highest degree that divides each term of the polynomial. So this one is just the distributive property in reverse. So if we had AB plus AC and we wanted to factor out the GCF, we go to each term. So AB is one term, AC is the other term. The GCF, the greatest common factor that those two terms have in common, is going to be A. So we factor it out front. When we're factoring something out front, we're technically dividing it out front because it's the opposite of distributing. Distributing is multiplying. So factoring out front is going to be dividing. So we're going to be left with B plus C after we divide both of those terms by A. Then you can always check by distributing the A back in, make sure you get what you started with. Okay, so let's do some examples with factoring with GCF. So the first one here, we have 18x cubed plus 27x squared. So the GCF, let's figure out what that is first. So we have two terms. So we're going to do the GCF of the coefficients. The greatest common factor of 18 and 27 is going to be 9. So if you have to list out the factors of each one, go for it, and then you choose the largest one that they have in common. So remember, factors, things that multiply to that thing. So next, the factors of x cubed and x squared, the greatest common factor is going to be x squared. The shortcut for knowing the greatest common factor with variables, for one variable, for x in this case, it's going to be the one with the smallest exponent. So in this case, the smallest exponent was 2. So the GCF between x cubed and x squared is x squared. So what we're going to do is we're going to factor that out front and see what we have left over. So if we're factoring that out front, we're dividing it out front. 18x cubed divided by 9x squared 18 divided by 9 is 2. X cubed divided by x is x. Plus 27 divided by 9 is 3. X squared divided by x squared is 1, so they cancel. So that's our factored form. 9x squared times 2x plus 3. And then keep in mind you can distribute to check to make sure you did it right. Okay, next one, 5x to the 5th plus 18x squared minus x. So our GCF, so we go to the constants, or the coefficients rather, the coefficients. We have 5, 18, and -1, so they do not have a common coefficient factor. Next, we go to the variable, which is x, and then we choose the smallest exponent. So it's an exponent of 1 on the last term. So we're just going to factor out a GCF of x. So if we do that, we divide every term by x, we're going to be left with 5x to the 4th plus 18x to the 1st minus 1. So don't forget that minus 1 because negative x divided by the x that we factored out is still -1. Next one, make it a little bit harder. We have more terms here, or more factors. So 6x squared y to the 5th plus 2xy cubed minus 8x to the 4th y squared. So the GCF of the coefficients between 6, 2, and 8 is going to be 2. The GCF for the x factor, smallest exponent is going to be a 1 on the second term, so just x. Next, for the y factor, smallest exponent is 2 on all three of those terms, so y squared. So that's our GCF. So we factor it out front. And then we divide that by every term, and that's what's going to be what's left. So for the first term, we're going to be left with a 3x y cubed. Second term, we're left with, actually you're just left with y. Third term, we're left with 4x cubed, and that is it. So we divided every term by 2xy squared. We actually needed exponent rules for that, and that's what we were left with. Okay, and last one for this page, we have x squared times x plus 3 plus 5 times x plus 3. So we actually, it looks a little bit different here. We still have two main terms. We have this big term and this big term. So the GCF, first, the factors of the first term are going to be x squared and then x plus 3. Factors of the second term are 5 and x plus 3. They don't have any variable in common. They don't have any coefficient in common. The only thing they have in common is that x plus 3. So it looks a little different because that's a binomial factor, but that's okay. So what we're going to do is we're going to pull that out front, factor it out front. What we're left with when we divide it out, that first term that we're left with is going to be x squared because we divided off the x plus 3. Second term, we're left with the 5. So we're left with x squared plus 5. So it looks a lot different, right? Because we factored out a binomial rather than a monomial, but that's okay. It's the same process. So that is GCF, factoring, greatest common factor. The next one is going to be grouping. So not every polynomial is going to have a greatest common factor. So we might have to try it by grouping. And kind of a hint here, this won't always work, but it will work a lot of the times for us. If we have cubic polynomials with all four terms, meaning we have the cube term, the squared term, the x term, and the constant, we may be able to do it by factoring. That's kind of a good spot to start for that one. Okay, so here are the steps. It won't make too much sense until we do an example. We're going to rewrite the polynomial in standard form, so decreasing order of the exponents. We're going to group the first two terms together and the last two terms together with parentheses. We're going to factor out the GCF from both of them separately, and then factor out a GCF binomial like we did in the previous example. Okay, so let's see what happens with this first example. So we have x cubed plus 4x squared plus 3x plus 12. So we're going to, it's already in standard form. So we're going to group the first two terms together using parentheses and group the last two terms together. So now you're going to go inside of each one of those parentheses, treat them as two separate problems, and factor out the GCF. The GCF of the first one, x cubed plus 4x squared, is going to be x squared. Dividing that out, we are left with x plus 4. For the last set of parentheses, 3x plus 12, factoring out the GCF is a 3. We're left with x plus 4. So if grouping is going to work, we should have a binomial in both terms that is the same, which we do. They're both x plus 4. So what we do is we factor out that GCF binomial, and we're going to be left with x squared plus 3. And we're done. So that's grouping. It's only a couple steps, but you just kind of have to know the steps for it. So let's do one more of these ones. So 5x squared plus x cubed minus 2x minus 10. So first we have to put this in standard form. So it's x cubed plus 5x squared minus 2x minus 10. Okay, and then we're going to group it. So group the first two terms. When you're grouping the second two terms, you cannot put parentheses here. So do not put parentheses there, and the reason is because of the negative out in front of the 2x. Technically, you're changing the problem. That would get distributed then if you put those parentheses, making the 10 a positive 10. So that's not where they go. What you have to do is you have to throw in a plus and then put negative 2x minus 10. So that's kind of one of the things to look out for grouping if that term is negative. Now it's going to be the same concept. Factor out the GCF from the first one, which is x squared. We're left with x plus 5. We know we're going to want an x plus 5 left over in the second term, so that means we have to factor out a negative 2. And if we divided that out, that means we're left with x plus 5. So now they both have x plus 5. That's our main GCF. Pull that out front. Divide it out. We're going to be left with x squared minus 2. Okay, so that's how you factor by grouping. And notice that both of those examples were cubic. They were cubic with all four terms. Okay, so for the next thing, now we're going to be factoring trinomials in the form ax squared plus bx plus c. So trinomials, so we have three terms where the highest degree is 2. So for now, we're going to have the coefficient on the squared term be a 1. So we're going to be factoring x squared plus bx plus c. If we can factor it, it won't always be able to be factored. We can factor it like this. It's going to equal x plus or minus a number times x plus or minus a number. So the blanks represent just a number. Those blanks have to multiply to the constant c, and they have to also add to the coefficient on the x, which is b. So it's pretty easy once you get a hang of it. So let's kind of see why this happens. So let's multiply x plus n times x plus m. So n and m are just going to be some numbers here. So if we multiply these, this would be foiling, right? It would be x squared plus mx. Now distribute the n plus nx plus n times m. Those middle terms will combine as m plus n times x plus, and then the last term is plus n times n. Okay, so you can see here we have from the beginning, we have this n, we have this m. So you can tell right here that they have to add to the x term's coefficient, and they have to multiply to the constant term. So that's kind of the reasoning behind why that's what we're doing. That's how we're doing it. So let's do some examples here. So we have x squared plus 6x plus 8, and we want to factor that. So what we have to do is we have to think of two numbers. So first we recognize that there's a coefficient of 1 on the x squared, trinomial in this form. We have to think of two numbers that multiply to 8 that also add to 6. So two numbers that do this are going to be 4 times 2 equals 8 and 4 plus 2 equals 6. So we're going to factor it as x plus or minus something times x plus or minus something, and the numbers are going to be x plus 4 and x plus 2. Okay, you could, if you weren't sure, you just take it and you FOIL it back out and make sure you get what you started with. Next one, x squared plus 13x plus 40. So we need two numbers that multiply to 40 that add to positive 13. So if this can be factored, we know it's going to be x plus or minus something times x plus or minus something. Two numbers that multiply to 40 that add to 13. Well, 8 times 5 is 40, and 8 plus 5 is 13. So it may be easier thinking about the multiplication first and then just seeing if those numbers add up to your x coefficient. So this is going to be factored as x plus 8 times x plus 5. Next one, y squared plus 3y minus 18. So two numbers, if it can be factored, it's going to be factored as y plus or minus something times y plus or minus something. Two numbers that multiply to negative 18 that add to positive 3. So it's a little bit harder because we're mixing and matching the negatives and positives. So 6 times 3 equals 18. We know the 6 has to be positive because it has to add to a positive 3. So 6 times negative 3, is negative 18. 6 plus negative 3 is also positive 3. So we know those have to be our answers. So y plus 6 times y minus 3. We're going to do two more. So this one, we actually have to put this into standard form. X squared minus 5x minus 14. You don't have to do it, but it's going to make it visually easier to do. So two numbers that multiply to negative 14 that also add to negative 5. So x plus or minus something times x plus or minus something. These two numbers, it looks like it's going to be 7 and 2. And the 7 has to be negative. So 2 times negative 7 is negative 14. 2 plus negative 7 is negative 5. That's why we knew the 7 had to be negative. So it's going to be x plus 2 times x minus 7. Last one here, we have m squared minus 6m plus 9. So two numbers that multiply to 9 that add to negative 6. M plus or minus something times m plus or minus something. That's actually going to be negative 3 times negative 3 is 9. Negative 3 plus a negative 3 is negative 6. So you have to be careful here because anytime it's multiplying to a positive but adding to a negative, the only way that can happen is if they're both negative. So this is going to be m minus 3 times m minus 3. So let's just write this as m minus 3 squared since there was two of the same thing. Okay, so let's do the next thing here. It gets a little bit harder. For the coefficient on the x squared term now not equaling 0, we're going to have these two different methods for it. So technically these will both work. I'm going to do the first method twice, and I'll do the second method once, just because you'll see that it's kind of a pain in the butt. So the first method here, so if we have a monomial, or trinomial rather, a trinomial in the form ax squared plus bx plus c, so coefficient on the x squared is not equal to 1, it becomes a lot more annoying. What we're going to do is we can do it by grouping, and we have to do it by grouping by setting it up in the following way. So instead of writing it like this, we're going to write it as ax squared plus something x plus something else x plus c. So what we're doing is we're splitting up that x. That x, those two blank x's, have to multiply to whatever a times c equals, and they have to add to whatever the b term is, whatever the b coefficient is. So first, we have to multiply the leading coefficient a times the constant c, get a value. And then we have to think of two numbers that multiply to that value that also add to b. So we're just rewriting the bx term, and then once we have it set up like that, we're going to do it by grouping. So that's the first way to do it. It's not as bad once you actually figure out the numbers. Then it's just essentially grouping after that. The second way to do it is by trial and error. So when it's in that form, ax squared plus bx plus c, it's going to look like the ones we just did, except the x terms in each binomial are also going to have a coefficient. So it's going to be something x plus or minus something times something x plus or minus something. So it's a lot more annoying here. So what we're going to do is the blanks, those blanks that we have to fill in, the first blanks, which are here and here, they have to multiply to a, and the second blanks, which are here and here, have to multiply to c. So what you're going to do is set up every possible combination that'll work, and then you FOIL each of them out until you get the one that is the expression that you started with, and that'll be the correct one. So it's trial and error, guess and check. Not very much fun, but we'll do that one last. Okay, so we're going to do this first method first here. So let's factor 2x squared plus 7x plus 6. So first we notice it's a trinomial in the form ax squared plus bx plus c. And then we notice that the coefficient on the x squared term is not 1. So we're going to have to set this up as 2x squared. We're splitting up the x term. It's going to be plus something x plus something else x plus 6. So all we're doing here is we just split up that middle term, and we have to figure out what goes in those blanks, and then we're going to factor it by grouping. So to figure out what goes in those blanks, we have to multiply a times c, which is the leading coefficient 2 times the constant 6. 2 times 6 is 12. So the blanks are going to be two numbers that multiply to 12. The b value here is the original x coefficient, which is 7. And our blanks also have to add to 7. So we need two numbers that multiply to 12 that add to 7. Those two numbers are going to be 4 and 3. So 4 and 3. So I'm going to rewrite this. 2x squared plus 4x plus 3x plus 6. And now we factor it by grouping. So I'm actually just going to group these together right now. So we group the first two terms. We group the second two terms. And we just factor it normally by grouping. First one has a GCF of 2x. We're left with x plus 2. Second one has a GCF of 3. We're left with x plus 2. So we got an x plus 2 binomial factor in both of these terms. That's how we know that we did it right. If we flip-flopped the 3 and the 4 in the beginning, if we put the 3 and the 4 in opposite spots, we wouldn't have been able to do it, and it wouldn't have worked by grouping. That's how you know to go back and change the positions. Okay, so last step here, we have an x plus 2 factor that we factor out, and we're left with that 2x plus 3. And then we're done. So it's not awful, but obviously it's longer than the other one. So let's do one more method this way. So we have 8x squared minus 10x minus 3. Okay, so for this one, we're going to split up the x term again. So it's going to be 8x squared plus something x plus something x minus 3. So we need to find those two blanks. We need to find first a times c, which is 8 times negative 3, which is negative 24. And our b value is the x coefficient, which is negative 10. So our numbers that we're choosing need to multiply to negative 24, and they also need to add to negative 10. So two numbers that are going to do this are going to be negative 12 and positive 2. So negative 12 and positive 2. So let's rewrite it. Make it look a little cleaner. 8x squared minus 12x plus 2x minus 3. And we're doing this by grouping once again. So let's group the first two terms. Group the second two terms. GCF in the first one is going to be 4x. We're going to be left with 2x minus 3. Second term, we don't even have a GCF. We just have 2x minus 3. Which is okay because now they're both 2x minus 3. So we factor out that GCF binomial of 2x minus 3. We're going to be left with 4x plus 1. So the 1 here is going to come from, so here's the 4x plus 1. There's always a coefficient of 1 if it's not written, so 4x plus 1. Okay, so that hopefully is not too bad for that one either. So for this last one here, so we're going to do this one by trial and error, so it's kind of going to suck. So first we have to rewrite this, 6y squared plus 19y minus 7, get that in the correct form. So for trial and error here, what we're going to do is we're going to come up with every possible combination. So I'm going to put possibilities over here. And we need to think of numbers that multiply to 6. Well, that can be 1 and 6. So what I'm going to do is have 1 times x, and then 6 times x. And then the second ones have to multiply to negative 7. So that can be plus 7 minus 1. We also can have it as 6x, oh, I'm going to keep the x actually. We can also have it as x minus 1 times 6x plus 7. So I just switch the second two terms. Okay, and then the other possibilities here, we can have two numbers that multiply to 6 be 2 times 3. So we can have 2x plus 7 times 3x minus 1. And we can have 2x minus 1 times 3x plus 7. So it starts to get a headache, to become a headache trying to get all the possibilities in here. And then, let's see. So we're actually only halfway done. So what I'm going to do, I'm going to move these last two down a little bit. I'm going to erase them for now, but I'm going to rewrite them in a second. And the reason is because I forgot 2 of them for the first ones. So we can still have x and 6x as the first ones. We can have two numbers that multiply to negative 7. Instead of 7 and negative 1, we can actually have plus 1 and negative 7. So just kind of double check, make sure you didn't already rewrite that setup, and we didn't, unfortunately. Lastly, we can have x minus 7 times 6x plus 1. So those are the 4 possibilities only using those numbers. Okay, so for the next ones, I'm going to do exactly what I just had written down. We can have, maybe not in the same order, we can have 3x plus 7 times 2x minus 1. We can have 3x plus 1 times 2x plus 7. This first one should be minus 1. And then we can have 3x minus 7 times 2x plus 1. And lastly, 3x plus 1 times 2x minus 7. So you can probably see that this way is not fun. You have to come up with every possible combination, and it does get confusing trying to come up with every combination. But that's it though. So what you would do once you come up with these combinations, you would FOIL all of these out. So you would FOIL these out, and whichever one ended up being 6y squared plus 19y minus 7, that would be your answer. So the one that ends up actually being it is going to be 3x minus 1 times 2x plus 7. So that one was right here. If you FOIL that out, you will get our answer. The annoying part here is when you're FOILing this out, every single one of these is going to have the correct first term and the correct last term. That's why we chose them. Only one of them will have the correct 19y middle term. Okay, so hopefully you think that first method is better, because that's how I would be going about doing it. But you do have this fallback plan. Okay, so that is 3 factoring methods so far. So for the last one, before we start combining them, it's the difference of 2 squares. So what this is going to be, it's going to be the reverse. It's going to be the reverse rule for multiplying conjugates. So remember, multiplying conjugates. Conjugates are going to be the same 2 terms. One is addition, one subtraction. So a plus b times a minus b is multiplying conjugates. What you end up getting is a squared minus b squared. So that in reverse is the factoring difference of 2 squares. So the 2 squares referring to a squared and the b squared. So a squared minus b squared gets factored as a plus b times a minus b. So let's do some examples here. So x squared minus 4. So we can factor that. It's the difference of 2 squares. If you have to write it out like this first, go ahead. It's x squared minus 2 squared. I don't recommend having to do that, but if you have to, go for it. This is going to be x plus 2 times x minus 2. So once again, if you have to FOIL that out, make sure you get x squared minus 4. So we can actually, another method that we could do here if you get completely stuck, x squared minus 4 is the same as x squared plus 0x minus 4, right? Just put in that 0 coefficient. We can actually factor this using the trinomial method that we did a couple pages ago. It's going to be x plus or minus something times x plus or minus something. 2 numbers that add to negative, sorry, 2 numbers that multiply to negative 4 that add to 0 are negative 2 and positive 2. So it'd be x plus 2 times x minus 2, which would be exactly what we just got. So hopefully you don't have to think about it that way, but that's technically the same thing. Okay, so next one, x squared minus 25. So this one is going to be x plus 5 times x minus 5. So the x from the x squared and the 5 because 5 squared equals 25. So the next one is a little bit tricky here. We have x squared minus 7. 7 is not a perfect square, right? The other two were perfect squares, 4 and 25. 7 is not a perfect square. So what we would say here, what we could say is that this is prime. But there is one other way to do this. I'm just going to maybe say note x squared minus 7. You could actually rewrite this as x plus radical 7 times x minus radical 7. So if you foiled that out, x plus radical 7 times x minus radical 7, you'd end up getting x squared minus 7. So it doesn't look clean. That's because it's not, because you have the radicals in there. But technically that is something that can be done. Or you just think of this as a prime polynomial. Next one, y to the 4th minus 81. So this one's a little bit harder. What you have to do here is recognize that y to the 4th is y squared squared, and 81 is 9 squared. So this is actually going to be y squared plus 9 times y squared minus 9. The y squared plus 9 is already done. However, y squared minus 9, that could be factored again as y plus 3 times y minus 3. And now we're done. So that one actually just had two difference of squares in it. The first one was just higher order degree 4. Okay, and then doing one more here, 81x to the 4th minus 16. So for this one, I'm going to recognize that 81x to the 4th is 9x squared all squared. 16 is 4 squared. So we can write this as 9x squared plus 4, which is prime, times 9x squared minus 4. So the first one's done. Like I said, this one's prime. Anytime it has a plus like that, it can't be the difference of two squares because it's not a difference. It's not subtraction. 9x squared minus 4 can actually be factored using difference of squares as 3x plus 2 times 3x minus 2. If you really wanted to, you could go back, distribute everything, make sure you get what you started with. That would be a pain, but it is doable. Okay, so that is all of our methods. So now let's actually combine these methods here. So I'll just do like several examples of this for combining. So we may need to do more than one in one problem. Keep in mind, always try to factor out the GCF first. It definitely won't always work, but just always try it first. So for this first example, we have 2x cubed plus 8x squared plus 8x. So recognize that there is a GCF because we want to try that first. The GCF is 2x. We're going to be left with x squared plus 4x plus 4. And then we can factor that trinomial x squared plus 4x plus 4. We can factor that as x plus 2 times x plus 2 because it was two numbers that multiply to 4 that also add to the other 4. Then we can rewrite this as 2x times x plus 2 squared. Okay, and then for b, we have 3x cubed minus 30x squared plus 75x. Once again, we have a GCF here of 3x. That would leave us left with x squared minus 10x plus 25. We can factor that trinomial, two numbers that multiply to 25 that add to negative 10. That'll be negative 5 and negative 5. So x minus 5 times x minus 5. So I'm going to write this one as 3x times x minus 5 squared. Okay, and then c, Negative 44x cubed plus 2x to the fourth plus 80x squared. So for this one, what I'm going to do is I'm going to write this in descending order in terms of the exponents. So get this into standard form first. So we get this. And once again, third time in a row, recognize we have a GCF of 2x squared. We're going to be left with x squared minus 22x plus 40. Trinomial again, so that's going to be two numbers that multiply to 40 that add to negative 22. So that's going to give us negative 20 and negative 2. So negative 20 times negative 2 is 40. Negative 20 plus negative 2 is negative 22, and that one's done. And I think this is the last one here. We have negative 3x to the fourth plus 15x squared. So when we have two terms here, our leading term is negative. Always factor out the negative with the GCF if it's on the leading term. So we're going to factor out a negative 3x squared. That would be our GCF here. So what we're going to have left is going to be x squared minus 5. Okay, so once again, we could say that we're done here and x squared minus 5 is prime, or you could chop it up as x plus radical 5 times x minus radical 5. I'm just going to say this one's done. So instead of doing that, I'm just going to say that one's done instead of splitting it up. Okay, so that one was almost difference of squares, but it wasn't. Okay, so that is it for section P6.